Topics in this overview to be covered will include AT33EV kit contents, instrument front panel controls, powering on the instrument, static test, connections and testing, dynamic test, connections and testing, and uploading and reviewing the motor test report. When you receive your AT33EV instrument, it'll come in a storage case that will store the instrument, its electrical accessories, and its software. When removing the contents of the storage case, we'll first start with the AT33EV instrument. This instrument will be used to diagnose and analyze motors and generators. As part of the accessory package, there are 3 leads that will be connected to the rear of your AT33EV instrument. These test leads are color-coded: blue, black, and red. They will be connected to the 3 phases of the motor and generator to analyze and test them. The next accessory that you'll find in the storage case is a yellow lead with a yellow clip. The lead and clip will be used to perform insulation testing on the windings of the motor and generator. To permit communications between the AT33EV and a computer, a USB cable is also included in your accessory kit. This will permit you to upload files from the AT33EV to your computer. Software is also included in your AT33EV kit. The software will need to be loaded onto a computer to permit communications between the AT33EV and the laptop in order to upload test data. The final accessory in the storage case is the AC adapter. The AC adapter will be used to charge lithium batteries in the AT33EV instrument. When you first receive your instrument, please ensure to fully charge the batteries prior to performing any testing on a motor or generator. And please ensure that the batteries are fully charged on any subsequent testing that you perform. Let's now review the front panel of the AT33EV instrument. On the front panel, there are 5 buttons. The first button is the menu button. This button will permit the user to select the test that they'd like to perform. The next 2 buttons are the F1 and F2 buttons. These buttons permit submenus to be functioned during the testing. The next button is the test button. The test button is used to initiate the insulation test on the motor or generator windings. The last button is the OK button. The OK button is used when a test will be performed. The OK button is pressed to initiate or execute the test. Located at the top of the unit are numerical designations 1 through 4. Position number 1 will connect the unit to phase 1 or phase A of a 3-phase electric motor or generator. Position number 2 will connect phase 2 or phase B. Position number 3 will connect phase 3 or phase C. And lastly, you have position number 4, which will be used only for the insulation test on the motor or generator. To this point, we have discussed the front panel of the AT33EV. We've discussed the menu, function, test, and OK buttons, and also the test lead positions 1 through 4 at the top of the unit. At the top of the unit, there are 5 connection points. The first 4 connection points are where the test leads will connect to the unit to test the 3-phase electric machine. The first position is for phase 1 or phase A. The second position is for phase 2 or phase B. The third for phase 3 or phase C. And then the yellow connection is for only insulation testing. These 4 positions make up the positions of where the test leads will be connected to the unit. The last connection point on top of the AT33EV is a USB port. This is where the cable will connect the AT33EV to the laptop or desktop computer. The final connection point is on the side of the instrument. This connection point is for the AC adapter for battery charging. Turning on the AT33EV instrument is a simple process. Locate the F1 and F2 buttons on the front panel, depress them simultaneously, and this will turn the unit on. Depressing the F1 and F2 buttons simultaneously, the screen will illuminate, providing you the following selections. After the instrument has been turned on, there will be 6 icons for you to select for testing. The icon on the left is the EV icon. This is the icon that will be used to test electric vehicle motors and generators. The next icon to the right is the DYN or dynamic icon. This icon can be selected when a user prefers to only perform dynamic testing on a motor or generator. Dynamic testing is when the motor or generator rotor shaft is rotated. The next icon to the right is the INS or insulation icon. This test is used when the user would like to perform insulation test on the windings of the motor or generator. The next icon to the right is the set icon. This icon will permit the user to set up communication between the instrument and the laptop or desktop computer. The next icon is the power off icon that the user can use to manually turn the instrument off. To select any of these icons, the user merely needs to press the OK button on the panel. Also on the panel is a battery state of charge indicator located at the very right. The first test with the AT33EV will be to baseline the stator winding state of health. This will be accomplished by connecting the blue lead to phase 2 or phase B of the electric machine and the yellow clip to a ground. Notice that the blue clip is connected to the blue port on the back of the instrument and the yellow lead is connected to the yellow port on the back of the instrument. The next step is to turn the instrument on by depressing the F1 and F2 buttons on the front of the unit. With the unit turned on, all the icons are present. Notice that the EV icon is highlighted. To perform the stator winding baseline state of health check, locate the OK button on the front panel and select OK. The instrument will now ask you to select the type of electric machine, whether PM servo or generator. PM servo is a permanent magnet electric machine. A generator is an induction electric machine. For the purposes of this example, we'll select the PM servo. The instrument will now ask the user to connect the blue clip to phase 2 or phase B and the yellow clip to a frame ground. After this has been completed, the user will push the OK button to continue. The unit will now perform a dissipation factor and capacitance test on the stator windings. Once this is completed, the instrument will ask the user if they would like to complete an insulation test on the electric machine. By using the F1 and F2 buttons on the front panel, the user can select No or Yes to perform the insulation test. In this example, we're going to select Yes to run the insulation test. Once Yes has been selected, press OK to initiate the test. The user will now press and hold the test button located on the front of the instrument. This will perform the insulation test. The resistance number shown on the instrument screen will indicate the dielectric properties of the stator windings tested at 500 volts for the user to evaluate. Once the insulation test has been completed, the instrument will ask the user to connect the black lead to phase 1 or phase A and the red lead to phase 3 or phase C and press the OK button to continue. Shown here are the black, blue, and red connectors of the instrument that are connected to all 3 phases of the electric machine to perform a static test. Once the user has finished connecting the black and red leads to phases 1 and 3 and press the OK button on the front panel, the instrument will begin performing a static test on phases 3 to 2 or C to B. Notice that there is a horizontal histogram that runs from left to right to provide the user an update on the progress of the test. Once the test on the 3 to 2 phases has been completed, the instrument will then begin static testing phases 2 to 1 or B to A. Once the instrument has finished static testing phases 2 to 1, the final static test will be phases 1 to 3 or A to C. Once the static testing is completed on phases 1 to 3, the instrument will then request if you would like to perform a dynamic test. To perform the dynamic test, the user will need to select Yes on the front panel by depressing the F2 button on the front of the instrument. Once Yes is selected, press the OK button to initiate the test. Once the dynamic test has been initiated by depressing the OK button on the instrument front panel, the vehicle drive tire will need to be consistently rotated at approximately 1 rotation every 5 to 8 seconds. If the transmission or motor is on the bench, slow and consistent rotating speed during the data capture is also necessary. To initiate the dynamic test, press the OK button on the front of the instrument. This will permit the instrument to begin acquiring data from the electric machine. This is the point where the tire would be rotated, transmission output shaft would be rotated, or the electric machine shaft would be rotated to acquire the data. At the conclusion of the dynamic test, the instrument will provide results for the parameters that have been tested. These parameters are resistance, stator, rotor, contamination, and insulation. The indications are provided in the form of OK, WARN for warning, bad, or NOR, which is no reference for that test. The user also has an option of saving the test as a reference, exiting the test, or uploading a test to a computer to view a full electric machine test report. At this point in the testing, the user can choose whether to exit the testing or upload the test to a computer. The instrument will ask the user if they'd like to exit now. The selections are no, yes, or upload the test. By using the F2 key and pressing it, you can navigate from left to right. After the selection's been made, push the OK button to execute your selection. After the test report has been uploaded to the computer, this will permit the user to populate areas of the report with important electric machine specifications and general test information. This permits permanent electronic storage of the test data. The next section of the motor test report is test results that were gleaned from the static testing. On the left, the values that were tested are DC resistance, stator, rotor, contamination, and insulation. To the right is the data acquired and displayed by the instrument for each of the areas tested. These tests permit a quick method of reviewing test data and comparing it to saved reference values data acquired from perfect through bad condition electric machines. The final and most important area of the test report is the test signature block. These signatures represent data acquired during the dynamic test. At the top of the test signature block, it can be seen that testing is performed from phases A to B, B to C, and C to A, and then the phases are compared to each other. The results of this testing are displayed in a horizontal line format. Phase winding state of health and rotor magnet or rotor bar state of health can easily be analyzed by using this signature. Stator condition can also be determined by comparing the deviation percentages at the bottom section of the test signature block.